Hello students, Dr. Wang is here recording. In this video clip, we're going to start a new chapter, the time value of money. So here, let me bring you a very interesting example. We have a baseball player here. His name is Albert Puyol. He makes a lot of money. So what you see here is a $240 million contract he signed with Los Angeles Angels, a baseball team. Well, I'm not sure how good he is, but definitely I want to be his money manager. So the compensation structure is like this. The first year he signed a contract is 2012, and he will make $12 million. As the year goes by, he will make a 16, 23, 24 until he makes $30 million. All right. If you add all these millions together, that is going to be $240 million. So that's why it's called a $240 million contract. Well, my question here is this a summation or is this a structure of a payment really worth $240 million? Is it the total summation we should use to measure the value of the payment or the value of this contract? Or let me put this way, between a series of annual payments and $240 million upfront, which one do you prefer? Do you prefer to be paid on an annual basis with these numbers, or do you prefer to get $240 million upfront all at once? Well, the real answer probably is you prefer $240 million get paid all at once upfront, all right? Because $1 today is better than $1 in the future. So if the total sum is the same, I prefer to have the number today. And this comes to the idea of time value of money. So $1 in the future definitely is worth less than $1 today in hand. So you prefer to have a dollar now than have it later. And if you have it now, you can deposit the money and keep earning interest as years goes by, as time goes by. And you will get more and more interest as you wait for longer and longer time period. So the interest is the money you make in actual of your principal. Interest is the price for borrowing money. Well, we use the money to measure the price of a lot of stuff and services. And how do we measure the price of money? We're gonna use the interest. So if we say this is expensive money, that means we're gonna pay high interest for it. If we say this is free money, that means we're gonna pay zero interest for it. We still have to pay it back, it's just with no interest. That's the definition of a free money. And also interest exists to compensate the lenders for delayed consumption. If I want to lend somebody some money, I better be compensated because I'm not using that money today. I'm satisfying my sacrificing my short-term gratifications for long-term success. So I wish to be compensated for that sacrifice. So here comes to the first formula for time value of money. So the first formula here is related with future value. So future value equals to the cash today you have multiplied by 1 plus the interest rate raised to the power of a t. Okay, interest rate is, as I said, is the price for money, compensation for delayed consumption, and that's the compensation for lending money. So what you do here is in order to get how much you have in the future, you need to know how much you have today times 1 plus interest rate raised to the power of t. And if you use Excel to do it, which you will do it in your second project, you gotta do a lot of time value of money solving using Excel formulas. So this is the formula for future value. So after you type in future value, FV, you have to first type in the interest rate and then number of years, and then payment, here is 0. Also present value, how much money you have today, and type defines the payment. So if you invest $500 in a savings account and earn 3% each year, so how much money would you have in 5 years? So this is a very easy calculation. You're going to use 500 right here times 1 plus 3% raised to the power of a 5. Okay, so if you look at your balance after each year, you start with 500. After 1 year, you have a $515. So that's 1 plus 3% times the 500 principal. And this will be your beginning balance of next year. You use 515 times 1 plus 3% again to get $530.55. And this is also 500 accumulated interest for 2 periods, compounding interest for 2 periods. So you can just keep compounding interest as the year goes by, and eventually you will have the ending balance of $579.64. The calculation here is very easy. Just use your calculator to do it. However, I do want to show you the way of using calculator. So the calculator you're gonna need is a Texas Instrument model 84 or 83 or 82 is also fine. So in this set of a calculator, you will need to define 4 factors out of 5 factors and solve for the 5th. So in this example, you define 4 factors, which is a number of periods, interest rate, and how much money you have today, and a payment. Payment is paid on an annual basis. It's a fixed amount each year, which occurs every year. But you don't have that payment, so you make it 0. Interest is not payment. Interest would be placed right here. And then you solve for the 5th factor, which is your future value. So the thing is, when you use your calculator, you have to keep in mind that the present value should have the opposite sign as future value. So there's a financial story behind it. The story is if today you deposit $500, if you put aside $500 in a bank, that's some cash flowing out of your pocket. So that's a negative money, negative cash flow. And then 5 years later, you expect to receive that money when you cash your investment. So this is a cash inflow to your pocket. So this is a positive. And if you put a positive 500 here, then the number you get would be negative. And your calculator, just like your Excel, recognize the direction of cash flows. So it has to make a financial sense, which means the cash flows in the 2 periods have to have opposite signs. The next one is to solve for present value. So this time you know how much money you have in the future, which is C, cash flow T. You discount it by 1 plus the interest rate raised to the power of T, number of years. And then you get the present value or the worth of the cash in today's dollar. Okay, so if you use the present value, this is a example. You need to have $40,000 in 6 years to use as a down payment on a house. So whatever you're gonna use it for, you need $40,000 6 years later. So this $40,000 is a future value. And the money will earn about 8% annually. How much do you need to invest today? So you're gonna discount 40,000 by 1 plus 8%. And then you have to discount it for 6 periods. So that's your denominator. And then you'll calculate your present value as 25,206. In your calculator, you gotta use N. You put 6 years for N, 8 as 8% for interest, and then you're gonna skip this present value, and then you put a payment at 0 because there's no periodical fixed amount of payment being made every year, so that's 0 payment. And then you put a future value as 40,000. You expect to receive $40,000 in the future, so that is a positive. Okay, that's cash inflow, and that would require you to deposit a cash outflow of negative 25,206. So this is how your calculator performed. For more details and how to use a calculator, I have set a separate video series just to teach you those calculator skills, in particular time value of money, basics, and advanced, NPV, IRR, effective rate, and also standard deviation. So you will look for those different separate videos for this calculator techniques. So for the class lecture, I just go with the pictures like this. Okay, so you will just need to know, you need to put in numbers for 4 factors, and then you solve for the last one. Okay, this is an Excel formula for calculating present value. So you start with a PV, then interest rate, number of years, payment is at 0, future value, and type. Okay, and we have of course, in Excel project 2, we will do more comprehensive practice on that using Excel formula. So you will get to that part. All right, now let's start talking about how to solve for the time period. So right now you deposit $5,000 today in an account paying a 10%. How long does it take to make your money grow to 10,000? So it is about solving for n, or number of years. In Excel, you're gonna start with the NPER, number of period, and then rate, payment, present value, future value, and type. Keep in mind that the direction or the size of present value and future value is different. So if you are solving for this question using your financial calculator, once again, it's about input numbers for 4 factors and then solve for the 5th. So what you have here is you solve for n after you define interest as 10, present value as negative 5,000. You see deposit, so that's cash outflow, that's negative. Payment as 0, future value as 10,000. And then you move back to solve for n, that's a 7.27. Now the next one is about solving for rate. So this time you're going to define n, present value, payment, and future value. So in this story, you are saving for your child college education. You will need $50,000 in 12 years. You have $5,000 to invest today, and what rate must you earn? So n clearly equals to 12. You have 12 years for investment, and you solve for interest, so just leave it blank there. And then you're gonna put a present value as a negative 5,000, so that's how much money you deposit. And then payment is 0 because you have no periodical same amount of payment made every year. The future value will be positive 50,000. So after define 5 factors, you solve for the 5th one, and then that will give you 21.15%. And that is a very high interest rate, very aggressive interest rate. You don't really possibly get in the real world. All right, finally, we're gonna talk about payment. All right, and payment is the very difficult part, the most difficult part, I would say, compared to solving for other factors. Right here, you have an example. You just borrowed $200,000 mortgage loan and will pay back in 20 years. The interest rate is 5%, and you assume that the payment is made at the end of each period. So what is your annual payment? So clearly you know that n equals to 20, interest is 5, that those are very easy to get. And you want to know how much do you need to pay each year to pay back this mortgage loan of $200,000. The story behind this is you borrow $200,000 from a bank today, so you can pay to buy a house, right? With that $200,000 loan, you can pay the house seller, so you can buy a house from that person. All right, so your present value should be positive 200,000. Although you're spending 200,000 to buy a house, the thing is, from the bank, you are borrowing 200,000, so that has to be positive. And then you have a 0 future value because your cash flows is only the 200,000 mortgage loan upfront and the annual payment for each year in the next 20 years. And there's no additional payment 20 years later in addition to the annual payment. So that's why you need to set your future value at 0. And then you solve for payment and make sure that if you put a 0 for the payment method, and in your calculator there's a way to define it as end. Okay, so that means your payment is made at the end. So your payment would be negative $16,049. So it's always a payment made at the end of each period for paying back loans like a house loan, a mortgage, car loans, or credit card bills. So it's always you borrow money first and you do not make the first payment until 1 month or 1 year later. And in some cases, you may get some advantages by paying it 2 years later or 2 months later. Okay, you do not pay the payment upfront. Otherwise, effectively, you are not borrowing $200,000. So if you make the first payment right the time you borrow the money, that basically means how much you borrow is $200,000 minus the first payment. So that's how much you borrow today if the payment is made at the beginning of each period. All right, and here's another example, and this would get a little bit more complicated because your payment is made on a monthly basis. Let's say you can afford a $400 monthly car payment. So what kind of cars can you afford if interest rates are 7% on 36 months loans? All right. So not everything here is on annual term. You have a 7% as an annual rate. However, you have the number of months for the loan you want to borrow. You want to know how much can you borrow based on $400 monthly payback. All right. So if you can pay $600 monthly, so definitely you can afford to borrow more money today and get a higher loan today. But you can only afford 400. So what is the amount of loan can you borrow? So with that amount of loan figured out, you should know what kind of car can you buy. So if you are able to pay $400 each month, you probably can buy a second-hand Toyota. If you can afford $4,000 each month, you probably can buy yourself a Ferrari. So whether it's 400 or 4,000 really depends on what kind of job you do. Anyways, so get back to this story. If you are going to pay back $400 each month, so how much loan can you borrow? That determines how much car can you buy. So you have to list every piece of information here. First is $400 monthly payment, and then 36 months in total. Your rate is 7% per annum. Annum means annual, each year. And then to do your calculation, you have to convert everything on a monthly basis, especially for this interest. You have to convert the annual rate to a monthly rate by dividing that annual rate by 12, the number of months in a year. So that's how you get monthly rate. Then when you put things in your calculator, you have a 36 month, and for the interest, you're gonna put the monthly interest or just a 7 divided by 12 in your calculator. The monthly payment is a negative 400. So you are paying back $400, so that's cash outflow. It should have negative sign. And for the future value, it's 0 because there's no additional amount of payment 36 months later. And then you solve for present value. That's roughly $13,000. So it's more like the average second-hand car in the United States. Okay, that's the price for the second-hand car in U.S. on average. All right. So just to echo what I just said, if you have a question like this, when the payment is made not on an annual basis, you have to convert everything to monthly basis. So this is the number of month, this is a monthly rate, and this is a monthly payment. All right, here is a very interesting example. So you have a BMW in your mind to purchase, and after you specify all these cool features, this is the price for the car, which is $54,125. All right, so that's your dream car. You are thinking to buy it. The thing is, you're not sure whether you can afford it. Of course, you don't have a $54,000 right away in your pocket in the box of cash. You don't have that money. But what you can do is to find a loan and then use that loan to buy the car and then finance that loan. So if you are choosing to finance the car, here are the terms. You need to make a down payment of $10,000. So let's say you have $10,000 cash in your pocket. That's how much you have for now for cash, and you can use that to pay as a down payment. And then you have 5 years to pay it back. So that's 60 months in total to pay back your loan. The rate is 3% each year. Okay, that's very important. The rate is on an annual basis, it's not on a monthly basis. And I want you guys to verify this a monthly payment of $793. Okay, so how do we get the monthly payment? So first of all, you should know that when you borrow money, you do not borrow the full price of the car, which is a $54,000. You are only borrowing price minus down payment. Since you already put in $10,000 of your own cash, you just need to borrow the rest, so which is $44,125. Does that make sense? All right, and then you try to estimate the monthly payment based on the amount you borrow, $44,000. So what you do here is you're gonna put everything on a monthly basis. Of course, this payment will be solved on a monthly basis, and you have to use a number of month, not number of year, and this interest rate is monthly interest. So you gotta put a 3 divided by 12 to give you 0.25%. All right, and then you solve for the payment, and that is negative $793 roughly. So that basically is consistent with the number provided by the BMW website. Okay. So in this case, as I said, you have to make the interest and payment and number of periods on the same page, all at monthly level. And there could be another way. Some people may think, okay, so this is 5 years, this is the annual rate. What about if I use number of years and annual rate to get the annual payment and then divide the annual payment by 12? So some of you may think, okay, 5 years, 3% each year, then I got an annual payment of this number, 9,600, and then divide that by 12 to get my monthly payment. Well, this way is the wrong way to solve for it. Okay, so this is the wrong way because the payment of each month should have different values, although the number is the same. So $1 in January is different $1 in December. $793 in February is different than $793 in March. So you cannot treat the monthly payment equally in a single year. Therefore, you cannot divide an annual payment simply by 12 to get a monthly payment because each month the value of the payment is different. Okay, the value in terms of present value is different. So $800 in January is different than $800 in December. So we cannot treat them as the same. So therefore, you cannot simply divide the annual number by 12 to get the monthly payment. So that's fundamentally wrong. But what you can do is to divide the annual rate by 12 to get the monthly rate, and then from that point calculate the monthly payment.